Hello, I'm Professor Seth Fry, and we're going to walk through Notebook 2 in our pipeline. So we just did anaphora resolution. We just did a bit of pre-processing to clean up your input policy text to make sure it's pretty much one sentence per line with explicit entities and readable and everything. So now we're going to open kind of the main institutional grammar notebook that we offer, which is Abdico subparsing.ipnb. I'm going to walk you through it. So if you already watch, and what it's going to do is it's going to turn a statement, each podling in incubation must report to the incubator PMC, which is just an example policy that is in our corpus. And it's going to break it up so that to identify the attribute, each podling in incubation, the object to the PMC, and the verb and the deontic, report and must. Now, again, that's not all of the institutional grammar. It's the four easiest and most common institutional grammar components. Is we want them to be available to you as out of the box as possible. Now, again, we're taking you through code. Code's scary if you can't do it. I'm going to show you where to click that you can run it and get useful outputs out of it and feel cool and exciting and capable, even if you don't actually understand how a lot of the code works. And I think that's okay because our motivation here is to not save the punchline of learning to code for 5 years after the joke has started, but to give you the punchline right away. Make the code useful to you in day one. That's your motivation to be curious about what's involved in tweaking the code to work slightly different for your purposes. So we're going to open. I've already walked you through this, but we'll do it again. colab.research.google.com, upload. I've already downloaded and unzipped our code, and so I'm going to open abdicoparsing.ipnb. And we're going to skip all this for now. I'm just going to run it. Okay, I ran this. I pressed play. You can see it took about 4 minutes. And then we're able to go down and upload data. So there are a couple options here. I'm going to run the data set that I've kind of pulled into this analysis that I haven't tested on this before, just so we can see everything work and look for anything unexpected. On top of that, there is this data set, which we provide. I have to kind of, there it is, policies co-ref. And then there's a third data set that I'm going to show you that will be in this notebook. That'll be right here in this notebook as well. And it looks like this, Colorado aquaculture. What's important about this data set, so here's a raw institutional statement. It's going to have the title raw institutional statement. That's going to be, if you're bringing your own data, you'll either run it through the previous notebook, and the output of that notebook will give you a column called raw institutional statement, and you don't have to do anything. Or if you're not running the prior notebook for pre-processing and skipping straight to this, you'll make sure there's a header row, and in the header row you'll create a column called raw institutional statement on the column that you want parsed by institutional grammar. So in addition to having that column, it has an attribute column, a deontic, aim, and object column. Well, the point of this notebook is to create those columns, and it already has those columns. So what's going on? Well, these columns were hand-coded. And so what we're going to do, in addition to taking a notebook that has not been parsed already and parsing it, specifically this one. So we're going to do both. We're going to take this CSV file, this list of policies that has never been touched, and parse it and extract the object, the attribute, the deontic, and the aim. Additionally, we'll take this data set, which has been processed already, right? Where was it? I just had it. I'm so confused. sorry. There it was. We're also going to take this other data set, and I'll just open it for us right now, that we want to automatically code, but we want to validate. So it's one thing to produce an extraction and publish it. Who knows if that extraction is good? What you'll tend to want to do, the best practice methodologically for using these tools, is you're not completely making all hand coding go away. You're going to do a bit of hand coding, even if it's just a couple dozen sentences. And on those, you will run the last part of our notebook, which after performing a computational automated decomposition of the institutional statements here, also performs a comparison against, you'll need 4 columns with these titles. One will have to be called attribute, one will have to be called deontic, aim, object. If those 4 columns exist, then the last part of the notebook that you're going to see is going to compare the newly generated columns against each of these columns and actually give you accuracy scores that indicate how successful the algorithm was at matching the hand coding scores. And it's not going to be perfect, but it doesn't have to be perfect. Just publish. You can get away with, you'll skim the data and you can get away with publishing the values we get that you're given. So let's start by running that data set. So I'm going to choose this Colorado aquaculture regulations data set. Should we run this? Okay, good. Colorado aquaculture, excellent. Then this one line, these 3 lines do the decomposition. This could take a while. I chose the aquaculture data set partly because it's hand-coded, partly because it's short. So we'll get a sense of what we've gotten ourselves into. This data set has 40 statements, 40 institutional statements, and so we'll see how long it takes to parse. Oh, 22 seconds, so that's not bad. What is it? It's half a second per line. You can see that, scaling as things get bigger, but it's not bad. And already we can download the data set and then examine it and print it out. So this is an opportunity here to just sort of see what happened. It's not very skimmable because I can't read the whole statement here. So we will look at the downloaded data. Good. So I'm going to call this let's see, main parsing output fishery. And then let's open it up and see what we got. So here we have the raw institutional statement. And what I'm going to do, I'm just going to fiddle a bit. Here we have attribute inf means inferred. Inferred. So I want to take the attribute inferred column, and I'm just going to move it so we can do a side-by-side comparison with the attribute common. And same with deontic, same with aim. Deontic. Deontic tends to do well. Aim does pretty well. And object. Okay, great. Okay, then I'm going to See, look at this. Shall, may, shall not, shall, may, shall. So that's good. That's it's approaching 100. It misses some here. It doesn't the automated is this column here, and almost overwhelmingly, any deontic it identifies is matched perfectly by the one that the hand coder identified. And where it doesn't identify them, let's see what's going on. Let's read this. The members of the board shall be as follows. One member who may be an employee of the division appointed by the director. So the way that got parsed, one member who may be an employee of the division was the attribute according to the hand coder, whereas none was identified by the algorithm. Shall, none, be, follows. So there's some disagreement there. But now let's look at aim. So we have overall a great match. Hand-coded, algorithm. Forward, perform, act, convey. We have a disagreement between be conveyed and forwarded. But then exercise, condition, review, refill, appoint, approve, review, elect, be eligible versus be, serve. It's very high quality. This is the algorithm doing an excellent job of matching the hand coder's work. There's also, matching between the objects, hand-coded and automated, but less upon a vote. Those are great, right? But then we have proposed rules versus to the commission. It becomes easier to find mistakes in the object. But still, when it does align, it's shocking and impressive and pleasing, very satisfying. I'm satisfied. And then we can do the same with director. So we have director, the director, fish health, the fish health, board, the board, commission versus it, fish health board versus the proposed rules disapproved by the fish health board. So that's going to be a mistake, but it includes the right answer, which is something. And actually, further down our pre-processing pipeline, these would get identified as the same thing. Sorry, our post-processing pipeline. Overall, the matching of the attributes, as you can see, it works really well. It's working better than the objects. And objects tend to be the least used by scholars in IG, so we're in a nice position that the most used are the most reliable. That's the output of this. The next thing to do in the notebook is to take this and test and validate. And that brings us to our last section, calculating accuracy. So it may be the case that, it's most likely the case that you have a lot of data that has not been parsed. It may be the case that you have a small sample of data that you've hand parsed, and you want to be able to compare in your paper. I find this very important. In your work, you want to be able to report the accuracy of the automatically extracted labels. So if you already have hand-coded labels, then you can run this code with whatever file that you uploaded above and downloaded the labels for. Just keep running this notebook, and you'll calculate the accuracy here. So once we download this, we'll get a sense. And what it's doing is you need columns with these specific names, with this capitalization, and it will read those and compare them to the attribute underscore inf. I say sub instead of underscore. The object sub inf, deontic, aim sub inf, columns one by one to calculate F1 scores. F1 is kind of like a % accuracy correct, but it's slightly more nuanced to allow for rare labels. The upshot of F1 is a classification task like fraud detection in credit cards means detecting very rare events, let's say 1 out of 1,000. Well, a way on fraud detection to get 99.9 accuracy, it would just be detect no fraud ever, because it's such a rare event that it only happens 99.9 or 0.01% of the time. So accuracy fails to evaluate the effectiveness of that fraud detector, because it just always says, because that fraud detector just says there is no fraud, and it seems to be very correct. F1 is a more nuanced measure that takes into account the fact that fraud is rare. It's basically calculated over your false positive, false negative rates, rather than just your percent correct. Anyhow, so I'm just describing this as our evaluation chugs away. It is a bit slow. We're only evaluating 150 statements here. There we are. So now it's reporting F1 scores for each of the components: attribute, object, deontic, and name. And 76. F1 goes, like accuracy, goes between 0 and 1. 76 means an F1 of 0.76. It's considered not groundbreaking, it's great to break 9, it's great to break 8 or 8.5, but it's fine, especially for large scale work. What you're saying isn't that we found the attributes, but that the attributes we found, or the things we found, are highly correlated with, or highly related to being an attribute, highly related to having the quality of being attributes. Also, keep in mind, this is a fairly strict comparison, so this is correcting for the fact that there might not be a the, is the policy the same as policy? This evaluation measure we've developed is it's a text comparison, which is slightly different than 100% right, 100% wrong. So there we are. Really fantastic performance on deontics, quite good performance on aims, very satisfactory performance on attributes and objects, which are much more free-form and open-ended. So inherently more difficult to detect. But overall, this is the performance of this. It's going to continue calculating. Here, I'll just stop it. On several other data sets it has access to. Well, so with that, let me review. We have automatically parsed. We have institutional statements. They've already been broken up into essentially one institutional statement per line by running all of our boilerplate, by uploading our data of any type we like. We have computed labels, downloaded those labels, compared them, and computed the accuracy of. And then for the subset of data that we have hand-coded labels for, hand-coded parses for, we've compared accuracies to the ground truth of human coding in order to be able to demonstrate rigorous use of this approach by reporting its accuracy relative to expert coding. And with that, thank you very much. I hope you enjoy the notebook.